Okay, I think we're at time, so let's begin. Hello, everybody. Welcome. Welcome to another monthly edition of Software Guff Gaff. As you can see in the screen, our agenda for today. So I'm going to first go ahead and introduce the group a little bit. So Software Guff Gaff is an online community of Nepali identifying people who are interested in the topic of software. The current context is that there is actually quite a bit of talent interested in software engineering, Nepali identifying folks. And the reality is that the diaspora is pretty much all over. So we wanted to, the goal of the community is to host monthly events so that the community has a space to come together, to share, to teach, to learn, to network, to help each other out. This is primarily an online community. We have a group on Facebook and on LinkedIn. We are always looking for community members to get involved, and there are many ways to do so. First, you may share a project that you might have worked on or talk about any topic that interests you related to software and technology. We are also always looking for people to help out in the organizing team. So if you're interested in volunteering maybe 1 hour a week, we would love to have you on board. And if you're interested, please do reach out to either Pramod, Prathana, or myself. So today's speaker is Sabin Timalsena. I've known Sabin for, I think, now over 5 years. We're in Seattle together. He worked at Microsoft and I was at Amazon. He's worked at Microsoft for 5 years and is currently doing a gap year, becoming more of an independent developer, indie developer. He has always been interested in arts, and drawing, painting has been his hobby ever since he was a young kid. Um, and I personally know Sabin as a very creative and artistic person. His projects have always inspired me and entertained me as well. He's one of the most creative people that I know, and definitely hardworking as well. He's done many visual experiments in many contexts, from QBasic ASCII games to high school geometry processing and research in grad school. Drawing upon that experience, he's discovered programming as a way to express himself by combining elements of art and music in his programs. And as you can see in the screen over here, I'm gonna play as I speak. I'm gonna mute this because the audio is gonna be pretty horrible. So this little demo over here is a combination of three different things. First, there's music, which unfortunately you can't hear, but there's also projectional mapping. So there's like a function between the music and the visuals. The music is kind of coordinating with the visuals, and there's also real-time object tracking, which I think is happening in the position of the guitar. I'm sure Sabin can explain a lot more about what's going in here because he actually created this. So without further ado, I want to give it over to Sabin and have him start the presentation. So Sabin, um, the floor is yours, the virtual floor.
Thanks for the really nice and flattering introduction, I would say. Yeah, but yeah, this is an interesting project that I worked on earlier, where I'm tracking the position of the guitar in real time and sending that position to a different program, which is driving the visualization based on the music that is playing at the moment. So yeah, this is like I can talk about the implementation details later towards the end of the presentation if any of you is interested to hear more about it. But without further ado, I'm going to start sharing my screen, which will stop obviously screen. And I will briefly talk about what my experience has been with creative technology, and what are some of the examples that I've come across, that I've studied, and some of the prominent artists in this field, and also the technologies that you can use to create stuff as a programmer or as an artist who wants to use technology. So this is this is the question, like, what is creative technology? So it is I don't want to get hung up on the definition. You can all choose your own version, but this is what I think. It is like when somebody combines elements of technology or science or math or anything, technology related to something in the art world to, not just achieve technical accomplishment, but also to create something that is aesthetic and pleasing, and to create new experiences that are not possible with traditional media. For example, the traditional arts, like, you might be painting with acrylic, you might be painting with oils. What if you use a robot to do that painting? Or, what if you simulate an acrylic painting using software? Or, what if you use something else, from the science and tech world to drive your artwork? So yeah, anything can be your canvas and technology is your brush. So this is what I think represents creative technology. So I'll give an example of how different elements can be combined with art. So on the top right corner, so you'll see two equations. So this comes from chemistry. So when you mix two chemicals, they react together in a certain way. And then, chemical A reacts with chemical B and it produces chemical C. And then, it will change the concentrations of the two chemicals, of the three chemicals. So then, this is called a reaction diffusion experiment. And using these two formulas, you could run a 2D simulation to create patterns like the one you see on the bottom. And then you could extend this to a 3D grid, and then you could generate a 3D design that you can then 3D print to create this sculpture like the one you see here. And then you can additionally distort the shapes that you generate using mathematical techniques to make it more complicated. So just an example of how you can take one concept and then apply different different kinds of technology, different kinds of algorithms to that technique to generate interesting results. By the way, if anyone wants to try this experiment, I have a sample 2D implementation on GitHub, and I can provide the link to that later. But yeah, so this is something that I really liked, and really represents the power of combining different kinds of algorithms and techniques to get creative. Yeah. So I'm gonna go with some examples of some of my favorite artists, beginning with Vera Molnar, who created art in the 1950s before computers were accessible. So what she did was she would devise algorithms, and then she would run those algorithms herself. Like the patterns that you see on the left, those were not generated by a computer. She did them, by acting as if she is the algorithm. So I find this really inspiring, and what a lot of the modern generative artists do is also similar to this. And then moving on to the next example, present day, Zach Lieberman is one of my favorite artists and also one of my favorite educators. He's a teacher, and he does daily algorithmic sketches, using code to generate interesting patterns, interesting shapes, and then he publishes his work daily on Instagram. If you like, generative design, or if you want to see, more of this kind of stuff, you can follow his Instagram account. It's a really good place. And then he also has a lot of open source stuff, and he also is an educator. He founded something called the School of Poetic Computation in New York, which is kind of like a hub for artists who, for creative coders and generative artists. And then, so yeah, this is one of my other favorite artists, Imogen Heap. She built these gloves, which are called the Maimu gloves. I think they're about $1,500 or something per pair. But what you can do with this is you can drive musical performances in real time using these gloves. So it's kind of similar to motion capture, but more geared towards musical expression. You can control synthesizers and instruments, and then use that to drive your performance. And I think this is really cool. And then here's another example, Refik Anadol. So his studio uses artificial intelligence to generate media. And they specialize in like very large scale visualizations. For example, this is the Disney concert hall in LA, and then they projected visuals onto the entirety of the concert hall. And then the patterns, they are based on some kind of they call it a data painting, because the it's not random, it's based on some kind of output of like some kind of neural network. And I know I know that there's people on this group who are interested in artificial intelligence. So generative adversarial networks are really popular in the art world. For example, StyleGAN and CycleGAN. You can use things to do like style transfer from one painting to another painting, or to generate things that don't exist based on what you've trained it on. But anyway, this is one really good example of like how larger scale exhibitions have been using art and technology together. And yeah, so if you're in New York, there is a space called AR Tech House, which does exhibitions of this nature. And there's one coming to Seattle called the Van Gogh Experience, I think. And then there's one running probably in LA and San Francisco. There are a couple exhibitions of similar nature, and he's performing in one of them as well. So definitely check them out if you're interested. So yeah, so why do we need creative technology? What is the motivation for people to do this? And I think this is my personal motivation, which is to expand the knowledge of what is possible, right? So you can do certain things with the media that are available to you, and then you have the power of computation, you have the power of computers. So what new media can you introduce? What can you combine? What can you merge together to create new experiences? So it is a process of experimentation and discovery. So yeah, and I repeat this this sentence to myself like over and over many times, and I think this like really sums up the place of creative technology in society, which is basically a way to provide new media to people to create new kinds of artwork. So this is like a really good example of like improvisation. So Inigo Quiles is an artist and a programmer who is like I'm not sure if you're familiar with the word demo scene. So there used to be a movement, which is still there, which is like you write programs from scratch. You don't use any like external assets. You don't use any pictures. You don't use any 3D models. You generate everything from scratch in code. So it could be like a 4 kilobyte program that generates like vast amounts of like worlds and stuff. So this painting, this Greek temple, was generated entirely with code. Like Inigo Quiles did not use any 3D model or any any pictures to generate this temple. And you can see a part of the code for generating this geometry. For example, the columns are like basically like modulated sine waves, and then there's a section called floor at the bottom. So that is the code that was used to generate this geometry. And I have also put a link on this slide. I'll share the slides later. You can click on this link, which will take you to an interactive website. You can try modifying the code and then view the changes in real time to this painting as you modify it. So yeah, so this is a shader program, by the way. So which is essentially a program that runs on the GPU, and it generates an image pixel by pixel. So you can think of it as a program that runs for every pixel, and then it determines what colors are going to go into every pixel. And it's like really mind-blowing what people can do just with code, without using anything else, just just by using like shader programming. So this is like, one of the strongest examples that I've seen of people creating something out of nothing. And this is like, this is mind blowing for me at least. So I'm going to talk about, a few options that are available to people who want to create in the digital world, in the digital era. So there are a lot of creative coding frameworks available, which enable people to, create on multiple levels. For example, we have, on one hand, we have artists who don't have a lot of programming experience, and they just want access to the computational power to, they want access to algorithms to use in their own creation. And on the other side of the spectrum, we have like the really experienced programmers who can create their own tools, and they can create new tools for artists to use, and they can do stuff that's really complicated. So these creative coding frameworks, they are suited for both, both kinds of people, all of the people on the spectrum. And I'll give you some examples in the later slides, but basically what they do is they provide a way for the artist or the programmer to interact with various systems. Like you might be working on the visual arts, in which case you might be wanting to generate a video, or you might be a musician, you might be composing music, or you might want to modify the music based on some other devices, for example, the gloves that you're using. You might be wanting to drive the video based on the audio or the reverse, and you might want to use network devices to run like a large scale performance. For example, in concerts you have like laser lights, and then you have like fireworks, you have you have projectors, you have music, and whatnot. So you can, there are frameworks that will enable you to interface with all of those different kinds of media, and then help them drive each other. Excuse me. So, and one of the other distinguishing characteristics of these frameworks is that they also have like an extensive library set, which is quite often also community developed. So if you develop a tool and you want to make it available to other artists, it's like quite easy. And then I think the most important thing about these frameworks is to support experimentation by not standing in the way of the creator, which is like, provide a way to get results in little time compared to conventional programming. For example, I think this will make it really clear. So this is the simplest example in a framework called processing. Let's say you want to draw a circle, and you just need like 6 lines of code in order to draw a circle. But imagine like if you had to do the same thing in OpenGL, in C++, you would have to like write hundreds of lines of code. You would have to from setting up the dev environment to make sure that your code compiles correctly, setting up the OpenGL device, and then pushing the commands to the GPU to actually draw the circle. So those are the things that stand in the way of the creator. Excuse me. But yeah, so frameworks like this, like processing, which simplify the creation process, is what really like enables and empowers more people to adopt technology and to start creating. So yeah, I think processing is one of the most widely recognized and popular creative coding frameworks. It is just a dialect of Java. And yeah, so you just, it gives you an editor with a play button and a stop button, and then you write your code on this file, and then you hit run, and then yeah, it just compiles and then it runs. Yeah, so it's as simple as that. And I'm gonna present a few other advanced examples of things that might not be as common. For example, there's something called Touch Designer. You need a license if you want to perform commercially or at high resolutions, but this is a visual programming environment, which means You can compose your programs using a graph, like the one you see in the picture, but you can also write traditional code in Python or C++. So this is like really powerful in that I know that there's a lot of artists who have like a visual mind, and they like to think in terms of they like to think visually, and they want to see their results as soon as possible. And there is a really cool feature called live debugging, which is like whatever changes you apply, whatever values are being passed around through the graph, they are previewed in real time. For example, this video output of this node, it can change through the multiple stages, but you can preview the video real time. And it's not limited to video. Like there's a lot of other visual programming context, and you could similarly debug like numbers. Maybe there's a number, and you have a graph that runs like a mathematical, like some arithmetic on that number, and you could debug that number visually, like without creating a breakpoint. And the powerful thing about Touch Designer is that you can create and modify these graphs on real time as you're debugging them. You don't need to compile them, package them, although you could do that if you wanted to. But yeah, I think this is something that artists find really powerful, so that you just want to change one parameter, see how it affects the art that you're creating, and you don't have to wait. It's all real time. So yeah, so I put a link to the showcase for the Touch Designer on the slides as well. If you go to the link, you can find some like really cool things that people have created with this framework. And also there's a couple honorary mentions called VVVV and NotchVFX. Those are similar visual programming languages. VVVV is a C# based language, so you can also write, like if you're a C# programmer, you might find it interesting. Cool. So yeah, I'll give a couple more examples, then I'll probably stop for questions. But yeah, real quick. So there's also like the field of sound programming, and there's a language called Super Collider. So it's a system that is composed of two parts. It is a programming language which allows you to design musical instruments, and then it is also an audio server which can interact with other programs. So you can write like sockets, network socket programming to send commands in and out of Super Collider, to trigger sounds to drive the instruments that you design in Super Collider. Yeah, but this is like a really powerful algorithmic sound synthesis system. And then also, yeah, some of you might find this interesting. There's a culture called algo rave and live coding. So what happens is, musicians, they go on the stage and then they code their music live. Like they're not using digital audio workstations like Ableton or Fruity Loops or anything. They're writing code. There are a few functional programming languages like tidal cycles and extempore, which are similar to Haskell. I think they are built on top of Haskell. And then there is a language called Foxdot, which is built on top of Python. So you could write code in these languages and then generate music in real time. Yeah, I find this really, really cool. And then, yeah, and they are often paired with like generative visuals, like someone, the same artist might also be coding the visuals that go along with the music, at these events or these parties. Yeah, so let me wrap up this slide and then I'll stop for questions. So there are like other general purpose creative coding frameworks similar to processing, which was the first example that I showed. My favorite is Open Frameworks, which is C++ based, because you get you can use your favorite editor like Visual Studio or Xcode. I think the debugging experience is better than processing. And then there's another library called Cinder, which is also really popular in the C++ world. And there's a new one called Nano, which is based on Rust. So if you need an excuse to learn a new language, because Rust is getting like really popular, this might be a good opportunity. Like, you can pick up this framework and then, try to draw like, interesting things, try to do interesting things with this framework. Yeah, and then there is a new one called P5JS, which probably might be the most accessible out of all of these because it is browser based and you don't need an editor. You just go to a website, you start coding. And then there's also a really nice book which I will share at the end of the presentation, which is both inspirational and educational, and it has examples in P5JS. And also, like, you could use game engines if you're like comfortable with programming, comfortable with building your own libraries and tools. And in fact, I use Unity for most of the things that I do, even though like Touch Designer would have like built-in support for many of those things. And then yeah, you can basically pick up anything that supports scripting or programming. So for example, you could write a program to generate interesting 3D models in Blender, or you could draw interesting like simulations in Houdini, and you can even program audio workstations like FL Studio or Reaper, yeah, to change your music or to compose music. All right, so I'm going to stop for questions. Let me know if you have any.
I have a good question. You showed us this slide about this stadium, Disney Stadium, right? And
yeah,
I didn't catch the last part. What was the inspiration for this again? What is that stuff?
Yeah, so yeah, but maybe like I'll do a recap of what's going on here. Hey, can everyone hear me?
Yes.
Okay, cool. Yeah, because my video was stuck for a while. Yeah, so Rafik Anadol is a media artist. He has a studio, and their studio does a lot of things, and they specialize in large scale visualizations. Like for example, there are exhibitions where you might find like 20 different projectors and like 40,000 pixels being projected over like a really large building. So they build visualizations for installations like that, and they also visualize on top of existing architecture. For example, this one, and then yeah, so their studio uses machine learning to drive their visualizations.
Cool, thanks.
Yeah. Yeah, and they're performing in LA, I think. I forgot, LA or San Francisco, like around this time. But yeah, if you search for this artist, you'll definitely find a lot of really cool things that they have done, and similar spaces where other studios or other artists perform as well. Cool. Let me just quickly check on the time.
Yeah, we do have time. I actually have a question as well.
Sure.
I'm curious about you showed so many different tools for doing visual art and programming. What's your process in choosing the right tool for the project? In a sense, like, does it depend on the project itself, or do you have a particular like a go-to tool that you normally like default to? So I'm curious a little bit about that process.
Yeah. Yeah, I do have a go-to tool, which for me is like open frameworks and Unity mostly. Open frameworks because you can just write like bare bones C++ programs. Like you just want to write a parser for to read a file for which no parser exists or no library exists. Then the easiest way to do that might be to just like write your own library in C++. And open frameworks is just a library on top of C++. It gives you the functions to make things easier, but you can like combine it with anything else. But yeah, there is definitely a question of what you want to create. For example, if I was to create something for a concert, right? So for example, they have lasers, and then let's say they have lasers, they have projectors, and then they have audio. Then touch designer probably would be the best tool for the job, because it already has like established library of interfaces, because there are different protocols for talking to all of these different devices. For example, to talk to musical instruments, there is the MIDI protocol, which is kind of simple. You could you could implement it in your framework of choice with little effort. But once you start having more and more devices, for example, there is a different protocol to drive like lights and lasers. It's called DMX. And yeah, but if you get into a situation where you have to like reinvent the wheel just to communicate with devices or with other systems, then you will have little time to spend on doing the actual creation. And you will it's not fun if you're spending most of your time like programming and debugging, as opposed to like actually tuning the artwork, which is the the visible result that matters in the end. Yeah, but yeah, I think game engines are also like a really good candidate for advanced things, because they are like a really good programming environment for anything that needs to be cross-platform. For example, if you want to develop an experience and then be able to run it on Mac or Windows, or run it on a phone, then you can easily do it with Unity. And then it has all of the rendering capabilities, and then you can also use like third-party like libraries, like either C++ libraries for Unreal, or like C# for Unity, and essentially like anything that takes care of the boilerplate for you, so that you can get as fast as possible from idea to results. Cool. So yeah, did anyone have a question?
I have a question. So in the video we saw earlier, it was mentioned that there were three things going on, right? Can you talk a little bit more about what's going on in there?
Oh yeah, sure. So what I did is okay, yeah, you might find this interesting, because there were a lot of steps in the process. So the goal that I started with was to, so I have a projector, so I project the visuals from the projector onto my room. And then for static objects, I know where the objects are, so I can align them perfectly. But for moving objects, I need to know the 3D position and the orientation of the moving object. So I have a guitar, and then this guitar right here. So this is like a pure matte white guitar, so that I can project interesting visuals on top of it. So it was actually the reason that I got this white guitar. And then so what I did is I needed a way to track the 3D position of this guitar. So the HTC Vive, which is a VR headset, it also comes with trackers, which are additional like little things that you can stick onto arbitrary objects. And then like you could put it on your hand, and then when you have the VR headset on, you can see your hand, where your hand is in the VR world. So I used only the tracking part of that technology. So I did not use the headset, but I stuck that tracker onto my guitar. And there are like 2 laser stations which can precisely calculate the position relative to the station that is tracking the tracker. So the additional problem there is like, now I have like 3 different worlds. So there is the real world in which the actual physical objects are. So it has its own coordinate system. And then there is the Vive tracker world, which has its own different coordinate system. So the coordinates of my guitar are going to be different on both of these systems. And there is a third one, which is I was also using a Kinect to 3D scan my room, so that I know where the walls are, where the floor is. So there is a third coordinate system. So there was like quite a bit of work that went into aligning those 3 systems, so that when I know, this is the XYZ, this is the rotation in this system, how do I translate this to the other system? So yeah, I spent like, probably like 1 or 2 months figuring that out. And then, yeah, when that was done, yeah, then I put together the rest of it in Unity. Like, so the audio that, I play through the guitar, it goes into Unity, it changes the visuals, and then, the visuals, I have the calculations running inside Unity to figure out the virtual position of the guitar in the virtual world. And that way I can get like an accurate alignment of the visuals. Yeah, so that's the summary. Yeah, I'm glad you asked, by the way. Thanks. Cool. So yeah, I don't think I have like a lot of yeah, go ahead.
I had a quick question as well. Like all these things about tools and technologies and like I don't know, different devices. What's your learning process like, in a sense that like as software engineers, we're heavily dependent on like Stack Overflow. Like so is it mostly that you look at like documentation of the tools or books, or is there like a maybe a community that kind of supports each other and teaches people, or maybe there's a course out there that kind of like gives you an intro to all these tools? So I'm a little curious about what you do when you kind of know that this tool kind of is what you need to get things done, but you might not actually have a very good command of like the tool itself. So I'm a
Yeah,
little curious about that process.
yeah, definitely. I think you had 2 questions in that one question. So I'll start with the tooling part of it. Like, for example, let's say you want to create interesting things in like processing. Then definitely there is like a big community of people who will answer your questions, and there's like a ton of documentation that you can go browse and figure things out. So that is the aspect of knowing how to use the tool. But the second aspect is like knowing how to implement algorithms, right? So let's say you want to for example, this example, the first one that I showed. So there you have a formula for this reaction diffusion system, and you want to implement this formula to generate a simulation like this. You can find like articles from people who have done it before. You can find example code, but in the end, it is up to you. Sorry, it is up to you to have to have some experience about like maybe computer science, which might give you an edge in being able to implement systems like these. But yeah, I think this is one of the things that artists who don't have a computer science background struggle with. Like they are able to use all of these frameworks like Touch Designer, processing, open frameworks, and so on. But there is a little bit of knowing about algorithms, knowing about data structures, the computer science fundamentals that you also need if you want to do something complicated. For example, if you want to do something in Unity, you cannot just go look for documentation, because you first need to understand, the GPU architecture. How do GPUs work in general? Like if you're trying to write a program that runs on the GPU, then you can do some like general stuff. But if you really want to harness the full power, then you need to understand the architecture of the system that you are using, and computer science in general. I think this is the biggest opportunity here lies for computer science students, because they do understand like the deep details about these systems, or if they need to, they can go figure it out. Yeah, but also you asked me about like what is my process in implementing like these things. For example, I've been experimenting with a lot of like fractal geometry, and then the Droste effect, like infinite spiral stuff. So that one was actually, I was looking at the works of an artist called MC Escher. So he is like a really old artist, and from before the computer era. And he used to he used his own intuition to create like really complicated mathematical shapes. And then, 30 years later, after when he created those works, like, professors in a university, they cracked the mathematics behind his work, and then they published it. So I was like, I started reading that paper, and then, so I started like, implementing like a small part of that paper. And then, I got a really nice spiral, and then, oh, this is cool. What else can I do with it? So, I tried adding like a texture to that spiral. So now I have like a thing, like a drawing that is turned into a spiral. And then, I took that further, like, okay, what would happen if like, I do the same thing in a 3D world. So I like, created like a scene where a character is moving. And then, I ran the same thing with the same mathematical technique. And then, I got some really interesting results. So I think a lot of it is like, you spend enough time on a technique to be able to find, how to get interesting shapes, like interesting results out of it. For example, with this reaction diffusion experiment, you have to find the right values for all of these constants in the equation, like this K and F, and then, this dA, dB. If you just pass in random values, you just get garbage. You won't get anything useful out of it. But, once you figure out like, what values work, like, how do you stabilize this experiment, then you can, think about combining this with some of the other techniques that you use. And then, I think that's really powerful, being able to combine multiple techniques.
Yeah, so I have a question. So can you hear me?
Yeah.
Yeah, so I was going through your Instagram, and like you have really cool works. And like I was wondering, like, like how much of it is like coding? Like, is it like 50%? Like, I mean, you probably still have to do like manual work, like, mixing and then all those stuff.
Yeah.
So like, yeah, what's the percentage? Like, what's the ratio? Like, how much is coding and how much is, just
I would say 90% is coding.
90%?
Yeah.
Wow.
Yeah, I spend a lot of time coding. For example, well, thanks by the way. So I was working on this like this, generative butterfly sketch, which is like, you just have like a sprinkle of dots on a rectangle, and then, you can change the distribution of the dots to make it look like something. So I probably spent like 10 hours working on the algorithm, and then probably spent like about 1 hour to actually make it look good, like to get the butterflies, get them to generate the visible results. Yeah, but yeah, I think I'm spending like 90% of my time programming.
Well, cool. And then I like the one where the cake is rotating, and then there's a
Oh, okay, yeah. Well, yeah, that one is, that one has little programming. Yeah, that one was like, my friend had a birthday, and then I just wanted to give him a cake, and yeah.
Yeah, that was cool. So that was like you use Unity for that?
Yes. Yeah, also, oftentimes what happens is like, there is a library in Unity that I have been developing, and, I've been working on that for like over a year. And, now, since it is like, quite developed, I don't have to do much, additional work to, for example, if I want to do like a new music driven visual, I can just reuse whatever I've already created. So, in those cases, there would be very little programming involved.
Cool. Yeah, so like you create programs according to your workflow, and then so it's easier for you.
Yeah.
Cool. Nice.
Cool. I think there was one last thing that I wanted to mention. So let me go back to where I was, which is this. Yeah, so, even though there's frameworks like open frameworks, processing tools designer, there is no reason to be locked down to like, to whatever is available, as long as you can code, and, you can easily find a way to connect one system with another. For example, people often like, go into debates about, okay, should I do like, Unity or Unreal or like processing or open frameworks? And I think, those discussions are moot, because you can pick whatever you want, and then you can build on top of it, and you can even combine like Unity with Touch Designer. You can find ways to pass data between applications. You can find, there are established protocols for like, interchange. And I think that's like the real power of technology, to not be locked down to one commercial product that is published by one company, but you can, you should feel empowered to, to modify whatever is available. There's a lot of like, open source tools these days. And then, yeah, and almost all of the graphical packages or the audio packages, they all support the scripting. So if you know Python, if you know C++, then you can do amazing stuff in like Blender or Houdini or any of these softwares. And also you can write your own programs to generate output that is accepted by some of these other frameworks. So yeah, I think the possibilities are endless. Yeah, and this is the last slide. If anyone is looking for some inspiration, this book has like a lot of like really good examples of how generative design has evolved, and it even has code examples. The examples are in JavaScript, but it doesn't really matter. You can just look at one and try to recreate it in any framework that you want. But I think the point that this book makes is you can take like something that is really simple. For example, impose like an arbitrary limitation on the way you create. For example, let's say you only want to draw a line. What can you create just by drawing a line? Let's say you just want to draw a circle. What can you create by only composing circles, like a large number of circles? So it is like, it is kind of an exploration of shapes at the most fundamental level. And yeah, I think if you found this talk interesting, I highly recommend this book. It's worth taking a look. Cool. Yeah, that's all I had for today. Let me know if there's anything else that you would like to ask me.
How long have you been in this field?
Yeah, so I've been programming for a really long time. I started doing computer graphics in high school. So I made a Snake game. I made like a Street Fighter game in QBasic, and then then I did a lot of like computer graphics in C++. But those are more on the technical side. So that's like the background that allows me to experiment efficiently. More on the aesthetic side, I would say more like 2 or 3 years, which is when I really started exploring these frameworks for creating like aesthetic results, not just something technical. Because the stuff that I did in grad school, like my master's thesis was to turn a cow into a dinosaur. So you give it like 2 3D models, it moves from one to the other. So that's more on the technical side, but it doesn't really look aesthetic. But I could take that same algorithm and make it combine it with some narrative, make something meaningful. Then only it becomes art. So I think in that sense, I've been involved for like 2 or 3 years. Cool.
Sabin, I wanted to ask you a question as well.
Go for it.
So you are kind of, I mean, you do multiple things, right? So you play music, you draw, you do this creative coding, and you're not just a creative coder, but you do other kinds of art as well. I was wondering, like, what kind do you enjoy the most?
I guess anything that challenges me. Where something, whatever gives me the opportunity to create something unique, I would say. Something that I have not seen myself. If I'm able to create something like that, then that makes me really happy. And also the synergy in combining multiple elements. So this is I discovered when I started doing these music visualizations. For example, I recorded something, and then okay, I think this would be really nice, if there is an environment that moves according to the music, and then I tried it out, and yeah, it was like really satisfying. So the combination of multiple elements and the a way to challenge myself to basically to expand my own knowledge of what I can do.
Cool.
Cool. Yeah, I think we're almost at time. Yeah.
Yes. Thank you, Sabin, for sharing your presentation and answering questions as well. Now I'm gonna pause the recording, and then we're gonna break out into any informal discussion.